It's a great privilege to be here today and talk about some of the enabling technologies that we're working on at Qualcomm and collaborating across the industry to bring to market. And I really resonate with some of the comments of Vice Chancellor Brown. It's so exciting to see the technologies that we work on every day, the potential they have to solve real problems in our communities, as well as do things that enhance the lives of all of us. So I really feel privileged to work in the automotive segment right now and also be able to leverage a lot of the initiatives that Qualcomm has on enabling technologies like 5G and machine learning and other ways. So I'd like to share a little bit of the vision that we see, and I think a lot of the industry sees, in terms of how some of the enabling technologies like 5G and machine learning can enable a whole new generation, a whole new area of smart transportation. And I think the vision is clear, but all of us are going to have to work together to solve some of the remaining problems and build out an entire ecosystem that brings this vision to life. So what are the things that are transforming automotive industry today? It's a very dynamic time, and it's an opportunity where the entire ecosystem of the car is changing, be it electrification, the fact that cars are all now being connected to the cloud, and then they're being deployed with much richer sensors and compute capabilities that allow them effectively to start to perceive the entire world around them and start paving the way to a future of autonomous driving. So at Qualcomm, we started working in the automotive space, bringing our modems into the cars about 15 years ago. We were part of some of the original deployments with GM OnStar that brought emergency services using 2G, 3G technologies. And this is an area that's expanded quite a bit over the last 15 years. Now we're already working with several OEMs on specific designs that are going to bring 5G into cars over the next couple of years. And so the exciting thing that's happening right now is this started as almost a niche of cars that had cellular technologies. But now everybody in the industry pretty much accepts the fact that within the next decade, essentially all cars will be connected to the cloud with cellular modems. And an interesting thing that happens is a lot of the market projections are saying that in the next 5 years, about 3 out of 4 of the new vehicles will come with integrated cellular modems. But what we're seeing supplying these technologies to the market is that the adoption rate is moving even faster than that. So what we've seen is every year over the last couple of years, we had projections of the penetration rate, and it's actually even exceeding those projections. And when you add cellular technology into your car, in the past, a lot of that was for emergency services, but now this is going to become more and more integral for what cars need to do in the future. The complexity of electronics that's coming into the cars and the amount of software that's there in vehicles today makes it essentially in the future pretty much an essential capability that you could have over-the-air upgrades of software in your car to be able to adapt to changes in the market. And so those are things that I think are really exciting that are happening in the car and are being enabling by bringing cellular into those cars. Certain other things happen when we integrate our modems into a car. One of those is we bring the capability to bring GNSS with very precise positioning capabilities into the car. When you start talking about autonomous driving, being able to know exactly where you are, both in a local aspect on the road as well as an absolute aspect, is going to be one of the most essential technologies to be able to fulfill some of the things we talk about in this presentation. Another thing that's happening is the telematics unit in the car is becoming essentially a Wi-Fi hotspot into your car. So these systems have the latest Wi-Fi Bluetooth technologies. You can enable connectivity to the cloud to all of your portable devices in the car, and eventually be able to connect the cloud to all of the different sensors in your car, all the different legacy systems that are there that might need software updates and other things. Now this brings a lot of new challenges. How do I protect the security of my car when it's exposed to the external world? So a lot of these technologies are very essential aspects of bringing together some of the things that need to happen for this smart transportation future. So Qualcomm has been able to grow very quickly in the automotive space, and it's a very key market segment for us now because it's a very large market. And one of the things that's happened is there's a lot of cars that get produced every year, but also there's more and more electronics content in each car. So today, your typical car has about 80 to 100 different electronic control units or computers in your car. So the scale of electronics in the car is very large, and it makes it a very large opportunity for us. We've already established a leading position in telematics and Wi-Fi Bluetooth connectivity, but about 5 years ago, we decided to also enter the infotainment and compute space in the car. We announced our first infotainment application processor at CES in 2014. That particular device was adopted in the market by Audi and Honda, so we were able to penetrate that market. At that time, we had to bring together a lot of the things that typically you don't do in a consumer application processor, like bring in things like extended temperature support, bring in packaging that's well suited for automotive designs, meet AEC-Q 100 qualification. So those are things now that we've become very experienced at and have the scale to do. Our second generation product came out a couple years later, and that's been very successful. We've had a very large number of OEMs that have adopted that platform. And now we've already introduced our third generation that's at 7 nanometer technology, and with that, an even larger amount of success. And we'll talk through the impact that some of those technologies are having now in your car in terms of enabling, more intuitive and natural experiences in your vehicle. So basically, as we've been able to bring these application processors into the car, it's coincided with almost an insatiable desire for having more visual connectivity in your car, more and more displays. And this is an example of some of the trends that are happening in the high-end car. We have customers that are wanting to drive anywhere from 10 to 20 different displays in a vehicle. So you have your traditional instrument cluster that used to be all analog in the past. Those are becoming digital cockpit experiences. You have your infotainment center that used to be in the past just a radio, but now it's become the center for navigation in the car. Those displays also typically now bring in the sensors in your car, be it a rear view camera display or a surround view display. But you can start to imagine all kinds of new things, like your mirrors become digital mirrors that can have alerts that get overlaid on top of them. Rear seat entertainment displays in the back of your car for your family. Other things that will become more important in the future, like the ability to have heads-up displays. So, we already see prototypes where you could project your navigation actually onto the windshield of your car, and it could be giving you very visual navigation directions without you having to look down or look to the side to a display. So these are very interesting things, and they're happening in the market. Other things are happening as well, like premium audio experiences. So you can imagine in a rideshare technology, you might want to have multiple different zones in your car where people could be having independent hands-free conversations on the phone, with that being isolated from the neighbors and other people in the car. Another app that I actually resonate the most with is growing up, we had a big Suburban and we enjoyed doing trips with our family. And that's such a big car that when the kids were sitting all the way in the back seat, the third row, it was very difficult to have a conversation with the road noise. But you can imagine now we have technology for in-car cabin communication where you could talk very naturally to your kids in the very back row of your car. So those are really neat things that I can relate a lot to in terms of what we could bring. Another thing that's happening is augmented reality might start to play in these HUD displays. And machine learning is becoming very big. So an example is being able to do voice activation for your navigation is still something that doesn't work as well in your car as we'd like it to. So can we bring enough compute and algorithms that we could do actually real natural language interaction with my navigation system and with entering commands. Those would be very helpful because it could stop having you tweak to enter the address or do things that are not very productive and shouldn't be done for the safety in the car. So one of the things that's happened, we mentioned the 80 to 100 ECUs, but every year cars are bringing in new capabilities. And the thing that happens is these cars, it's not like all of a sudden people can afford to pay twice the amount for their typical mass market car. So there's a constant pressure that as these features come in, it's features that customers want, but it has to gradually fit into a same price window that it did before. So getting really advanced silicon technology that can integrate that onto fewer devices is really important. So what we've seen happen is that in our first generation, we had an infotainment display, and we were typically driving 3 different displays. For the instrument cluster, we didn't drive the full instrument cluster because there's safety requirements in the market. For example, your odometer gauge should never drop a frame. And your telltales that give you warnings should have ASIL safety compliance and have freedom from interference from any other application that's going on. So what would happen in those early devices is the infotainment SoC had a powerful graphics core that the cluster didn't. So it would generate the map and send it to be overlaid in a regular old-fashioned cluster device. As we approached our second generation, the cluster and the infotainment device got integrated onto one chip. And at the same time, we're starting to add surround view, which was a separate system at that time, all on that same chip. We drive the rear seat display. We add enhanced audio that was a separate system. And we're driving more displays. So what happens now is all those features that could only be used in premium cars start to come down to the mass market and be affordable. So right now, all 8 of those functions that used to be separate computers in the car are now being done on one Snapdragon device in our current generation. So that makes those features much more cost effective. And then what happens is the industry's moving so fast, more ECUs pop up for even new functions that haven't been thought of before. So one of them that's happening now with artificial intelligence is driver monitoring. So if you have a GM function that does their Super Cruise for a highway pilot, they have a camera that's supposed to constantly monitor the driver and make sure that you're really paying attention so that if you have to engage and take over driving, you'll be able to. Right now, that's a separate computing system in the car, but we can already see one generation from now that will also get integrated into the same device. So with that, we need even more machine learning capability and more processing. So what's the key to this? It's basically having highly optimized application processors, and they have heterogeneous computing blocks for every specific class of problem versus doing it all on one general purpose CPU or graphics processor. So what that does is it enables to bring very high performance concurrency at a very cost-effective performance and cost. The other thing that's really important is in your typical car you have very tight thermal constraints on these processors. And if you go to electric cars, it'll be even become another factor that the power consumption will impact the battery life of your vehicle, how many miles you can drive. So all of the things we've invested in at Qualcomm on power efficient architectures become very important in the car. And all of it has to be done with real-time support. So what's happening more and more is the real complexity in these systems is becoming in the software. And really millions and millions of lines of code going into a single system like this. And it's actually a weird combination when you start to try to bring together what I mentioned with the cluster, your rear view camera, and an infotainment system. Because you're bringing together the desire to be able to have the latest applications maybe that come with Android on your phone, all coupled with real-time safety critical systems that have to have certain certifications and be very hardened. So what's happened in the market is these systems have to be built on top of hypervisors. So in our case, we have multiple different safety critical hypervisors like QNX and Greenhills. And we can support multiple different operating systems running concurrently on the same chip. So for example, in this case, a QNX RTOS would be running the cluster display and the rear view camera. And then my infotainment system that might have a Pandora app that I can get integrated very quickly leveraging my Android ecosystem are all running together with separation at the software level and the hardware between these different domains and operating systems. Now, what does this have to do with smart transportation? You can imagine in the future that this same type of requirement is going to come to the cellular technology. So today, our next generation modems, in Europe, for example, most cars actually have two modems in the car. One of them is basically your e-call emergency services modem, which has a service that's operated by the vehicle manufacturer. And then you have a second modem that's the one that's being used for all of the user services, their dynamic media content and things that they want to enjoy. So that leads to all kinds of interesting combinations. Add on top of that you might want to do concurrent CV to X. And how do I make sure that the media experience that's being downloaded through the modem doesn't interfere with my safety critical CV to X communication that's a safety critical function. So I think everybody knows at Qualcomm we have a big focus on 5G and building from our previous LTE technology base. This whole 5G is all about enabling not just connecting phones, but connecting everything in the world. And automotive and the smart transportation industry, I think, is going to be one of the most interesting aspects of that has the biggest impact. So what happens when you bring 5G into these vehicles? It's just going to open up a whole new set of services and user experiences that are very important. The economic possibility here across all the services that could be offered into the car is very significant, which is why you see the entire industry, including all the tech leadership companies, now focusing a lot more on automotive. But what are some of the things that this will bring? First of all, vehicle-to-vehicle communication with cellular V2X brings a very important aspect, which you can have non-line of sight information into the car that you can't get just on the sensors in the vehicle itself that can only see a limited range. Also, going to 5G, you're going to have the new capabilities in CV2X that allow things like collaborative driving, intention sharing. So one of the apps that we demonstrated at CES this year with Audi and Ford and Ducati motorcycles is you all come up to a four-way stop, and how do you negotiate who should go first? And how do you do that efficiently? One of the things we showed is you'll be able to detect who was there first, and you coordinate and agree that they go first. But what if the car that came in fourth is actually going to go parallel to the first car, and they can go together, and there's no need for it to wait? So we were actually able to demonstrate that. That's a good demonstration. Now it needs to go to the next stage where that whole handshaking mechanism needs to become standardized through the application processes in SAE and other agencies. Higher throughput is going to be very important. One of the things that happens in a lot of the futuristic view of automated driving is a critical component could be an HD map, where your car has a map that has all kinds of landmark information that tells you about the road, and it augments the ability of the local sensors. Those maps might require a lot of data, and you can imagine in the future one of the problems with those maps is they get stale very quickly. So what if you could have a future where every car driving, if it detects something new, like a new obstacle in the road, he could upload that new information to the cloud. You could have crowdsourcing of the maps, and that could be updated. So it's going to be very important to have high throughput for these types of concepts and services. Ultra-low latency is also very important. If you want to do anything that involves helping to give rapid response time for emergency braking or other things, those need to have very low latency. And then finally, ultra-high reliability. So if I'm relying on this handshaking mechanism at the stop sign, how do I know if I transmitted something that the other side actually got that messaging correctly and agrees with what I want to do? So those are actually new features coming in release 16 and beyond on the C-V2X standardization efforts. So we've talked already about C-V2X, but it's really starting to take root in the industry. We've been part of establishing an organization called 5GAA that's a broad industry alliance behind this technology. There's over 100 companies involved, and various companies are taking stands. At CES, Ford announced that by 2022 they're going to introduce C-V2X on all of their vehicles. And so this is an industry of vehicle-to-vehicle communication that has been trying to get going for over 15 years, and it's been very difficult. You know, we tried to go through processes of getting government mandates. It hasn't happened. So I think now's the time that we need to take this industry by the horns and just create the services and make it happen with or without mandates, because the potential is just too large in terms of the value that this can bring into transportation. In 2017, we announced our first chipset with C-V2X, the 9150. That's in full production now, so we're getting ready to have real deployments on this at a production level. And what's going to make the C-V2X approach to this very cost-effective is that our future roadmap actually integrates C-V2X concurrently with the same 4G and 5G modems that are already going to be in your car. So the cost to add this functionality is going to be very low at an electronics level. So that could start to remove the cost barrier that's prevented OEMs from being very aggressive in adopting this technology. So here's a look at the roadmap that we have. We've announced both 5G and 4G modems that have concurrent C-V2X enablement. And it's very important as part of this technology to have the application processor that can do the full ITS communication stack. Security is definitely going to be a key area here. If I'm getting all of these messages that describe, apologize for that, location of another car, how do I know that there's not some malicious agency that's introducing spoofing and other things? So we have a whole mechanism for secure credential management that's being proposed. Recently we bought a company that's the leader in the 1609.2 standard, and we want to make this an integral part of our whole system philosophy as we enter this segment. So here's some of the examples of what C-V2X can bring. We talked about non-line of sight sensing. So you could have a car coming from the left that I'm totally blind to that's trying to run through a stop sign. With C-V2X, I could be alerted of that technology. Conveying intent. So this, you know, one of the things, we have a full autonomous driving stack that we are developing that's using just the sensors in the car. But one of the things we have to do with that is use machine learning to do blinker detection. And it works reasonably well, but how much more straightforward would it be if I just had a vehicle-to-vehicle that actually tells me that the car has initiated a lane change? That's a much more straightforward way of addressing that need. So as part of this, the cars are going to start having more and more sensors that can do local perception and understanding of the world. A highway pilot or a Super Cruise car would have radar and camera. Those are the most cost-effective sensors, and really important to be able to do a lot of the perception on those entities. Your robotaxis typically would add LiDAR, but those are still very expensive, and it makes it hard to deploy in a mass-market vehicle. And then you have other sensors like ultrasonic that's good for parking assist and other things. But every one of these sensors has limitations. So the local sensors in the car don't have the range that you need to predict things that are coming. So you can start to supplement with C-V2X, the HD maps. And when you start using maps, it's very important to have a very precise positioning. So this would use things like multi-frequency, high-precision GNSS that's coming in our new modems. Dead reckoning technology, which we already have, where if the GPS signal is impacted, you're also tracking the data of the CAN bus on the speed of the car, you know, the gyro that's telling you the rotations that you're applying in your driving. We've got another technology that adds visual inertial odometry with cameras. And with that, we can take a standard basic consumer sensor for GPS and basically get meter level accuracy in the absolute world and 10 centimeter accuracy at the lane level. So that's a really key technology that's going to be very important both for C-V2X and autonomous driving. So what is it going to take to put the smart transportation together? It requires bringing a lot of different infrastructure components. And this can start with things like C-V2X-based roadside units. So this could be your traffic light has a vehicle-to-vehicle technology and can signal to cars when it's going to change the light. And the car could signal and also have the lights themselves monitor according to traffic. On top of that, there's a big opportunity that if the 5G rollout starts to happen worldwide, those could start to co-locate with roadside units. And this is the value of doing this with C-V2X technology versus some of the earlier proposals, is that the wireless 5G infrastructure deployment is going to happen. It's happening all over the world. So that's a very cost-effective economic way to start bringing these vehicle-to-vehicle and vehicle-to-infrastructure technologies to the market. These can then feed into centralized traffic management centers that understand the entire situation across all the roads and give very smart coordinated guidance to vehicles. Right now you can already start to get a little bit of that with Waze and other apps, but what happens when the app tells everybody the same thing? You know, how do you coordinate that? I was trying to beat the system the other day in a traffic jam, and I tried to drive around it, and every other car did the same thing, and it made things even worse. So you could imagine with this type of technology, someone could really coordinate and find the best solution at any given point in time to solve traffic problems. The other thing is stop and go traffic is mostly just an artifact of our human nature. But if you could all coordinate and drive at uniform speed, you're going to get much better density on the highways, much better fuel efficiency. So these are all things that could start to happen as this infrastructure comes together. We're seeing two interesting trends. One is obviously the sensors coming out in the cars and the fact that they're connected. So that will lead to the cars on their own being able to have some automation and do certain safety features. But on top of that, we're starting to see some of these roadside units becoming smart. So you could imagine a roadside unit that actually has all of the same sensor technology you might put in the car, like LiDAR and radar. And the roadside unit itself could create the whole real-world view and be sharing that actually with the cars themselves. And a car that doesn't even have autonomous capabilities or any of those sensors could get the benefit of all that technology being in the infrastructure. So one of the things that I think would be very interesting is you get certain highways where just like a toll road requires you to have a toll tag, you have to have C-V2X, and then these roadside units actually guide the entire flow of traffic. It's going to tell you how fast to go, and then that could stop all the rubbernecking and some of the stop-and-go challenges that we see on the road. To do this, what are all the technologies? Artificial intelligence, obviously, the sensors, multi-mode, 4G, 5G, C-V2X. All of these are enabling technologies that we have products today, and it's all about working together in the industry to bring this whole ecosystem together that's going to be required. Here's an example on highways. So in this particular case, this could be one of those roadside units that has cameras and sensors. And let's say that there was a car that spilled a mattress out. It would detect that and send advance warning to all the cars that are coming with vehicle-to-vehicle communication. This would be via PC5, so very low latency. And these cars would detect it and start to slow down. And maybe these cars behind it would then be aware of that by the communication between these two cars. And then you could avoid some of the rapid brakes and some of the things that lead to a lot of the accidents on highways. You know, on top of that, you could have these traffic-based monitoring advisories. And then you can imagine in the future, autonomous driving, cars without drivers at all, they may run into conditions where something happens and they don't know what to do. People are doing exploration on teleoperation where the low latency of 5G allows a data center to actually take control of a car if it gets into a situation where it doesn't know what to do. And then we've talked about the crowdsourcing of HD maps and what that could do. And then you go into an urban situation. Here it's a lot more complex. You have cyclists, pedestrians, crosswalks. One of the problems that a lot of the C-V2X community is trying to work on today in standards is how do I do things that reduce the number of fatalities that happen with pedestrians, because it's a very large thing that happens in the industry. And so here you could imagine this traffic light is monitoring the pedestrians and could issue a warning that someone is getting ready to cross the road and they're not aware that a car is coming. Now this all sounds fairly simple, but if you really tried to do it in a real system, how do I not have false alerts? Another thing we're working on is maybe the phone itself could have C-V2X technology and the phone could alert the pedestrian. But if I'm doing that, how do I keep this communication going constantly and not drain the battery of my phone? So these are some of the areas that we're trying to invest in smart algorithms. How do I make it power efficient? And I could imagine in the future every phone would have this capability. It could alert the pedestrian itself and alert the car. But the concepts are simple, but the making it deployable and real is still needs a little bit of work. So all of this is going to require a comprehensive ecosystem, and it brings together the automakers, the transportation infrastructure providers, the mobile operators will have a big say in this, the internet and cloud providers that are doing the maps and the traffic management updates, and then work on standards. A lot of the core standards on the messaging protocols and the RF requirements are already there. But now we get into a phase of higher level application standards like the coordinated driving at the stop signs that I mentioned. So a lot of work that still needs to be done. You can see in the previous slides, I think we all agree that the capability of the vision is there. But how are we going to make this realizable? And it'll probably be little small steps. So if we could even get a few basic features coming one by one, which is how things usually happen, we could start to reap the benefits of these technologies. So really exciting to be here and work together to shape the future of smart transportation. The potential is to have much better in-vehicle experiences, make the roads a lot safer, much more efficient transportation, which I think all of us have cases when we're in traffic jams that we don't want to be stuck in all the time. Automated driving has potential as well, and then a whole rich set of road services. So it's a really bright future and a lot of work for us to do together, bringing these technologies into the market. Thanks.
Thank you. This is a small token from us. Thank you very much. Thank you. But I would like to see if you have any questions. Maybe a couple of questions. Oh, good.
Okay.
Thank you. Questions? Yes. Yes. Go ahead. Oh, I'm sorry. Is there a microphone?
I think I can speak loud enough. Ricardo Tavares. My question is, you mentioned that we didn't have government mandate, so which means the government say by 2024 we all are going to have, we have to have V2X by 2024. So just
Right.
another example. Why do you think we didn't get there, and what would be the priority in your view in terms of what is the goal that would make sense?
Okay. Yeah, that's a complicated question, and it's been through a lot of ups and downs. I think over the last few years, there's been a lot of times where we thought we're months away from, mandate. It was considered, delayed, postponed. So I think at Qualcomm, our philosophy right now is getting some of the right things in place, like the spectrum availability, some of those things. And then, how do we go create pull for this technology with or without a mandate? Because we've been waiting for a mandate for a long time. And, let's find a way to get this done by the pull of the consumers, the value of the applications. And, I think that's the most pragmatic way to do that. And then eventually some of the mandates will come. But, we spent too much time, I think, depending on that. And now it needs to be more about just bringing the services and making it feasible.
What are your thoughts on DSRC versus the 5G? Because I know a lot of the equipment's going DSRC.
Right.
What kind of investment would you make in that, and is this competing or complementary?
Yeah. So at Qualcomm, we started working on DSRC, over 15 years ago at the beginning of it. And we do have DSRC products. And one of the decisions we took a few years ago when the mandates weren't coming was that we thought without mandates, the economies of scale on 5G and C-V2X would probably be favorable in terms of making it adopted in the absence of mandates. I think this is playing out all over the world. China has pretty much already gone full in on cellular technology for vehicle-to-vehicle. Europe is still very much open. There's a strong camp for DSRC. The U.S. had a lot of momentum on DSRC, but now with people like Ford coming and saying they're all in on C-V2X, we think it'll probably go that direction. Either way, we're going to be part of enabling the technologies. But our approach was really, we think, for example, as I mentioned, the scale of 5G deployments happening and then making that part of the infrastructure to bring this versus having to go deploy separate, city-driven investment on all these individual infrastructure components, might be a barrier in terms of, the affordability of doing that. Certainly over the last 15 years, that's been a possibility and it hasn't happened yet. The other thing is the technologies keep moving. So you can see 4G, 5G, higher bandwidth. Some of the things we're looking at with C-V2X, for example, are getting much beyond small basic, safety messages. So for example, you could imagine with Release 16 and 5G, I could not have just basic safety messages that say, here's the location of my car, how fast I'm going. I could actually do something where I share the sensor from my car with somebody else. So we did demos at CES, for example, where when there was a traffic accident, a car nearby could actually be sharing a view of the road with the emergency vehicle that's coming, so he's already aware of what's going on in that facility. So I think there's some pretty neat things about going the cellular route on this that will be very practical and have benefit. But either way, the biggest thing is to get vehicle-to-vehicle present in the market.
Maybe a last question. We are running quite late.
So Jeremiah, thanks for the great overview. Could you make a couple of comments about the security model and how you think that's going to evolve, and specifically where you see that playing from the physical layer versus maybe an application overlay in your processors?
Okay. Yeah, so at the low level, these chips have to be underlaid by basic security. So root of trust, mechanisms that can do the basic crypto, mechanisms. With the 1609.2 that's been established as the message security process, you basically have electric curve cryptography. So for our devices, things have been moving. Early on, it was like you might need to do 200 message verifications. Now it's become 2,000. So that requires having the right hardware in the chips. On the app layer, basically people will be deploying secure credential management systems that then create ways that you can validate this particular message is coming from a car that's been authorized to be on the road, use C-V2X, so that I understand that I can trust the information that it's sending. But those are all the mechanics. It's still very complicated. Like, what do I do if someone doesn't have an authenticated message? I know that, but then how do I feed that into the decision making that I'm doing? Or what if I see a message coming that tells me a car is here and he has an authenticated message, but the location isn't right because his positioning service is incorrect. So I think there's a lot of areas here where we need to go above the basic security infrastructure that's there, and at the application level be in robust solutions that can solve these concern areas that will be real.
Thank you very much.
All right.
Thank you. It's real good. And it's a honor and pleasure to have partners like yourself and Qualcomm. Not only the depth of knowledge, but your willingness to work together. Thank you very much.